Hello everyone, my name is Suhail Ansari. Today I will be presenting the paper titled CursorCore Assist Programming Through Aligning Anything. So these are the topics we are going to discuss today. So let's get started with the problem statement and the introduction. The problem statements that this paper states are limited real-time editing support. Current AI model focus on adding on completing code snippet, which does not meet the continuous editing need for programmer as noted in the paper. Insufficient prompt-based edits. The instruction model relies on specific prompt, slowing down the programming progress and reducing efficiency. Limited context usage. Existing model often overlook broader coding history, focusing only on immediate context, which limit their effectiveness. High user input demand. Many models require frequent user prompts, hindering the AI proactive support and overall effectiveness. Input-output constraint. The paper calls for more advanced model that integrates code history, current code, and user instruction for smoother and more efficient edits. So, so in the given figure, in the left side, it shows the current AI models, which is a traditional approach such as the completion and insertion modes. These models focus on generating or inserting code based on the immediate context, but do not support continuous editing or consider broader coding history. On the right side, it is the CursorCore framework. It integrates multiple information sources like history, captures past code modification, current code represent the code currently being edited, and user instruction U includes prompt provided by the user. The output from the assistant include both modified code and chat style interaction, enabling a more dynamic and proactive coding experience. So CursorCore aims to enhance the programming assistance by leveraging comprehensive information sources. So introduction to CursorCore framework. What exactly is CursorCore? So CursorCore basically is a collection of AI models that have been fine-tuned using a substantial data set of 219,000 data points. The primary goal of this model is to provide proactive and seamless support to programmer. So CursorCore, apart it is ability to align with both current code and its evolution, which allow it to offer optimal assistance during the coding process. So let's get into the main contribution or the solutions to the problem which the paper have stated. So the list of the main contribution that paper have stated are assistant conversational framework, Programming-Instruct pipeline, APEval benchmark, CursorCore model series. So now let's explore the assistant conversation framework, a new approach to AI-assisted programming that aligns all relevant information sources throughout the coding process to enhance real-time support for programmers. The key elements of the assistant core framework are system. This includes the initial instruction that defines the assistant style and behavior, shaping its interaction with the programmer. History. This captures code editing history, enabling the assistant to understand and previous changes and provide contextual relevant suggestions. Current code C refers to the actively modified code, including cursor position or selected text, allowing for precise modifications. User U. This encompasses the input or queries from the programmer, essential for understanding user interaction. An assistant A represents the assistant output, including modified code and chat responses, which are crucial for effective communication and support. So in summary, the assistant conversational framework integrates these elements to create a AI-assisted programming environment, significantly improving the programmer productivity. So, so let's talk about the benefits of the assistant conversation framework over the traditional modes. So here codes code C is shown as block with compressed history for larger code bases. So the traditional chat models rely only on the user input, but this framework considers a broader context for the code context, history, and user for a more robust coding ex experience. Enhanced contextual understanding and proactive responses provide a streamlined and intuitive interaction for developers, which can be hard to find in the traditional modes. So, so let's talk about the specification and implications. So, so the sequence of system history, code user, and assistant reflects programming steps, enhancing speed through prefix casings. So which also sets apart from the traditional way of AI programming. So given figure, in a given figure, it illustrates assistant conversational framework which integrates various input during the programming process. System provides the overall task description, history so the past code changes, which from the which inform the current code context. Current represent the code currently being worked on, and the user captures user instruction or feedback, and assistant output modified code and interaction with programmer. This framework allow for a comprehensive understanding of programming context, improving the assistant ability to provide relevant support. So the programming instruct pipeline is the second solution or the part of the assistant. So the programming instruct is a data collection method designed to automatically capture data from the program processes, addressing the challenge of limited annotated coding process data. By gathering the information from diverse coding resources such as AI-generated code histories, Git commits, and online coding platforms, Programming Instruct generates varied and rich data to train models on real-world coding practices. So on the figure, so in the figure highlights the diverse data sources used to collect programming process. So the AI programmer utilizes LLM to generate coding history based on various prompts, simulating different programmer expertise level. Git commit capture real-time code edit and modification history from the Git repositories, and online submit captures or gathers data from coding platform like LeetCode, where users iteratively modify and submit their code. This multi-source approach ensures a rich dataset for training our models, enhancing their ability to assist in programming tasks. The programming instruct pipeline efficiently collect data from three key resources: AI programmer, Git commit, and online submissions. So in the given figure, we can see the steps involved in our data preprocessing pipeline for programming instruct framework. Firstly, data is selected or time point is randomly chosen for coding process to represent the current state of the code. Secondly, the data is categorized into four types based on available information: historical edits, current code, and user interaction. Thirdly, the changes between version and segmented into individual modification allow for more granular training data. Uh, and in the last step, the model generate corresponding instruction based on historical edit and current code. This is a structured approach ensures that the data is well organized and represent of various coding scenarios, ultimately enhancing the model training for programming assistants. So this is the fourth solution or the benchmark that is created by the that is created while the CursorCore was made. So APEval is a comprehensive benchmark designed to evaluate effectiveness of language models in providing programming assistance. It measures how well model can utilize different types of information to enhance coding support. So the APEval evaluates four combination of information types: history, code context, user, and another one is history, content, and the third one is code contents and user, and the last one is only the code content. This approach mirrors real-world coding scenarios for more better assessment of programming assistant. So, so the APEval is built upon human eval by incorporating simulated programmer instruction and a wide range of coding tasks. It thoroughly tests model across diverse coding style and context, ensuring a robust evaluation of their capabilities. So the first of APEval utilizes pass at 1 and pass at k metrics. These are widely recognized metrics in the programming community for assessing code correctness. They help us evaluate how correct and robust the code generated by our model is across a variety of programming tasks. Moving on to the data com composition, APEval is made up of 164 diverse samples. These samples are divided evenly among the four types of informations we discussed earlier: history, code, context, and user. For history, we see a mean snippet count of about 2.8. The lines in the snippet range from 21.7 to 139, and the character count varies from 0.6K to 5.1K. This gives us a good mix of historical content. Next, for code, the average line count is 8.4 with character count ranging from 0.3K to 1.4K. This helps us understanding the current state of code being evaluated. Finally, for user intent, the mean line count is about 3.2 with character ranging from 0.2K to 1.2K. This captures instruction of goals from the user perspective. To ensure the relevance of samples, they are annotated by programmers with varying level of experience. This diversity is annotations provided us with a comprehensive view of coding behavior and help us capture different user perspective. In summary, these metrics are these metrics and our carefully curated data composition allow us to go thoroughly evaluate how well our model can assist in programming tasks. So for the robustness evaluation for real-world scenarios of APEval benchmark, APEval emphasizes realistic testing by evaluating how well model adapt to real-world programming need, including edit and instruction-based tasks that the coder face daily. Second, it offers variety encompassing program synthesis, code repair, and instructional edit. This ensures our model is assessed across different programming support scenarios. Finally, by aligning closely with real-life users, APEval help, helps improve model performance and enabling them to assist programmer effectively in complex tasks. So CursorCore models are a specialized family of AI models optimized for assisting with programming tasks. They are designed to understand source code, generate code snippet, detect error, and help with debugging. By leveraging large-scale code dataset and machine learning techniques, cursor models are fine-tuned by address challenges in software development lifecycle, improving both accuracy and productivity for developers. So in summary, cursor models are designed to significantly improve the coding experience for the programmers. So here is the comparison of CursorCore models and the other models and its key strength and weaknesses. So we can see that the key strength of CursorCore models is it is highly specialized in code understanding, generation, and debugging, optimized for real-time assistance. And the weaknesses for core cursor models are that it may require high computational resources. Similarly, for GPT-4, we can see the key strength are it is a broad general purpose language model with strong code understanding and general abilities. Its weaknesses are sometimes it lack domain specific optimization knowledge, and it also don't know that what is our coding, what is our history in our code base, and what is our code content. So cursor core models is also a advanced form of AI coding. So for the evaluation and result of the uh, APEval evaluation, so we can see that instruction tuned model typically outperforms their base version, significantly enhancing overall capabilities. However, the Queen 2.5 coder-based model, which achieved high scores due to extensive pre-training. In contrast, instruction-tuned version did not perform well. So in summary, while instruction tuning usually boosts performance, pre-training can also play a critical role. So Queen 2.5 coder-based models is also a cursor code model. So the performance evaluation of general versus code LLMs. In 1 billion plus parameter model, generally LLMs significantly underperform compared to code LLMs with a performance gap of exceeding of 10%. As we move to 6 billion plus models, the gap narrows, and by the time we reach to 10 billion plus models, the performance difference becomes negligible. In summary, while LLMs excel in low parameter range, the performance of general LLMs improve marked with increased size. So the performance evaluation of open source versus closed source models. The performance gap between open source and closed source models has significantly narrowed, with top open source models now approaching to performance of leading closed source model like GPT-4. Despite this advancement, closed source model still exhibits superior capabilities in processing and allowing various type of information. In summary, while open source model have made great stride, closed closed source model maintain an edge in certain areas of performance. So the limitations and the future work of the papers which was provided in the papers are repo level assistance and multi-file support to enhance ID integration, expand evaluation criteria to encompass multi-language capabilities and additional metrics, leverage human feedback for preference-based optimization, and integrate function call to improve efficiency while exploring application beyond programming. So this was my presentation for the CursorCore paper in which we discussed about discuss about the how the cursor core is made up of. So thank you.